Thank you everyone for being here. Exciting day. Like a cow walking through tall grass, I am utterly tickled to be here. So,
Utterly tickled. Oh.
Today we're talking about understanding dependencies in JavaScript to create a more performant app. As you mentioned, my name is Tyler. I'm a senior software engineer at Webflow. We are one of the companies in the visual development platform space, kind of that no-code, low-code website design. So super exciting space to be in. If you want to find me, you can find me in all the usual places, as well as my website, tylerhawkins.info. So as I began preparing this talk and creating content for it, I started digging in a little deeper, not just in looking in dependencies in your apps or in your React apps, but really trying to look at the makeup of them and looking at what all goes into the bundles that we create. So a lot of what we're going to be talking about is bundle analysis and looking at that within a React app.
Can you put that up
A
higher?
little higher.
Okay, and then I'll adjust it.
Sweet. Is that any better? No.
Should we go to plan B?
We could.
We also have this.
Yeah. Let's give that a minute.
I'll put this here if you fall back. Want to fall back to it, just push that button right there.
Sweet.
When it turns red, you can speak to it.
Thank you. Okay, can you hear me now? Is that any better? No. All right, do we want to keep going or do we want to switch to this? Switch, all right. Yeah, we can switch. Check, check. Is that better? Much better. Okay. Sorry about that. Let's start over. So we're going to talk about using bundle analysis to create a more performant app. We're going to look at the JavaScript and the makeup of our React apps and take a look at those bundles and make sure we're really only delivering to the browser what we need and what users need. So we actually had really great introductions to this in the last two talks for people who stuck around in this theater, from Matthias and from Brian. But one of the complaints from users and developers over the last several years that we've been trying to tackle for the last probably 5 to 10 years is that our apps are too big. We're delivering these bloated apps with just tons of JavaScript. As Brian pointed out, most of that, not most of it, some of that JavaScript is not even used or necessary. We're just shipping lots of code to the browser. These apps are too slow to load. They take a long time to load. They use a lot of data. As developers, we're often running on our fancy MacBook Pros and our speedy devices and our fast internet connections. So we don't notice this as so much. But other users do, right? People might not be on the latest and greatest devices. They might not be on the best internet connection. And so when our apps take a while to load, we get these frustrated users, right? And so what we're trying to achieve as developers and software engineers, particularly in the front-end world, is we want to make sure that we ship the right code at the right time. We want these small bundle sizes. We want to make sure that we've got fast performance. And we want, ultimately, happy users that can actually use our app and be pleased with the end result. And so as you look online, right, and as you look out in the tech world, there are a variety of ideas that have been presented to kind of solve this problem. Again, Matthias and Brian took us through an excellent history of some of the approaches and strategies that people have been using. So you come across a variety of ideas. You'll hear people say, just stop using React, right? You don't need a library or a framework, which might be true for some cases, right? Maybe React is overkill. Maybe you don't need a library or framework. We have many different other solutions, right? We can start using Preact or Svelte or SolidJS or Astra or HTMX. Many of these are trying to solve those same problems of shipping less code, being more performant, having smaller sizes of JavaScript. We've already looked at a big history of various rendering patterns, right? So we were doing React with just the client-side rendering. We switched back to server-side rendering. We tried doing that, and then we had the kind of performance issues, right? Of we got a quicker time to first paint, but a slower time to interactive, as we still need to download all that JavaScript and hydrate the page. And so we start looking to solutions for that, right? If we want to start trying to progressively hydrate it or selectively hydrate it. And now we have React server components. There's also islands architecture, right? So we have all of these different solutions and technologies and stacks and frameworks that are all trying to solve the same problem of making sure that we're delivering the right code at the right time. The problem with this is that these are not always viable solutions, right? This isn't a criticism of the solutions themselves at all, but sometimes we're not in the right place to be able to adopt that, right? Maybe you're already using React at work and you don't have the time or the resources or the desire or the skill set to totally re-architect your app or to start implementing some of these ideas. So this talk, we're gonna go kind of a different route. This talk is for the people that are doing more old school stuff. You're not on the latest and greatest technology. So perhaps you're already using React and Webpack in an existing code base at work. Maybe that code base has been around for the last 5 or 10 years. You've got an established app. You're doing just normal standard client-side rendering. You're starting to notice performance issues in your app, so you're taking note of those. You're trying to find ways to improve it. And so you want to get better, but without completely re-architecting your code. So maybe that's you. So that's what we're going to talk about today. That's our target audience. So I'm very much a visual learner. As we talk about these kind of concepts, the abstract tends to go over my head a little bit, and so I like to see very visual examples to kind of bring the concepts home. And so we're going to be looking at this awesome little Pokédex app, something I built for the talk. If you want to clone it or play around with it later, you can find that online. It's Bundle Analysis Demo. All right, so we're going to dig into this a little bit. So I'm going to get this thing running. This will be, hopefully will be okay without needing to type very much. All right, so here's our app. So it's a fairly small app. We've got our Pokédex right here. We've got the original Generation 1, 151 Pokemon. It displays them all here. You can mark them as captured or not captured, right? So you can go through here. You can sort by type, so we could look at just grass type Pokemon. We can filter them, go by captured or not captured. Within each one, we can click on it. We can look at a different Pokemon. We can even save that info as a PDF. So that's going to be using a third-party library. In this case, it's using JS PDF to create that. And there's also a tiny little about page. So that's the entirety of the app. It's a fairly simple app, but it's also not just hello world, right? So we've got we're using React and React DOM. We're using Webpack for a bundler. We're using Material UI for the components library. We're using React Router for client-side routing. And then we've got JS PDF for that PDF download. So again, small app, but it's not trivial, right? And so as we look at this, let's imagine that we've shipped this and users are using it, and we've started to get complaints that it takes a long time to load, right? And so as we go and look at this app, if we pull up our network requests in our dev tools, you can see we're just filtering for JavaScript. I've disabled the cache. It's just gonna load everything from brand new every time. You can see as I load the page, it downloads this one bundle here. So that main dot, the content hash dot JS. And as we look at that, we see that's 241 kilobytes of code. So that's our starting point for our app. 241, honestly, it's not massive, right? We saw earlier in some stats, some apps are like 1 or 2 megabytes, and that's massive, or you might have more hundreds of kilobytes, right? But that's our starting point. So let's imagine this is too much, and users are starting to complain. And so you can see as we navigate around the app, like as I click on things, like it's not downloading anything else new. If I navigate to another page, it's not downloading anything new. I could save it as PDF, still nothing, about, still nothing. So it's just the one JavaScript bundle that we've created. And so when you start looking at your bundle size, one of the first things that you want to do is get some visibility into the makeup of your bundle. And so one tool that you can use that I really like if you're using Webpack is called Webpack Bundle Analyzer. Just show of hands, anyone used that package before, that tool? Yeah, awesome. Got a handful, maybe about a fourth, a third. So this is a really cool tool. Webpack Bundle Analyzer, as you might imagine, is a way to analyze your Webpack bundle. You can use that as part of a plugin in part of your Webpack config, or you can use it separately from the command line. And so what I've done here is I just have this build stats command. When you run it, you can pass it the --stats flag, and that will tell Webpack to generate in your build this little bundle stats.json file. And that's just a bunch of metadata all about the makeup of your bundle. And then if we want to analyze that, we can do npm run analyze. And that's just going to run Webpack bundle analyzer on that bundle stats.json file. And so let's show you what that looks like real quick. So if we do npm run analyze, it pulls up this cool little analyzer tool. And so we've got this little visualization. Over on the left, we have this little panel. It'll show you the different sizes for stat, parsed, or gzipped. Stat is the unminified, parsed is minified, gzipped is minified and gzipped. So we'll look at gzipped since that's what's being delivered to the user in the browser. And so as we look at this, you can see we've got a few different bundles here. We've got this big green one over here on the left. That's our main that we saw, that main content hash.js. And then we have a few others that we didn't see earlier. So we're going to ignore these for now. There's this canv library, the HTML to canvas, and DOM purify. All three of those are coming as optional dependencies from JS PDF, and they've kindly code split those out for us. And since our app doesn't need them, they're not being downloaded. So we're just going to focus on this main green one. As you can see, it shows that it's 234 kilobytes. For some reason, that's lying to us. It was 241 in the browser, so not quite sure why it's wrong there, but it's close enough. And then if you want, you can even dig a little further. It says you can show the content of the concatenated modules. It mentions that it may be inaccurate. It's usually pretty accurate, though. So you can see in our code this little tiny sliver right here. This is the source code. So out of our app, that is our source code, that little sliver. And then we've started delivering this massive bundle of third-party dependencies. And that is the complaint on our React app, is why do we need so much code and so much JavaScript for this tiny little amount of code? Okay, so that's step one. We have noticed performance issues. Maybe we've got user complaints, so we're proactively monitoring it. We now have visibility into our app, so we can see the bundle that's created, and we know the makeup of it. So now let's start to try to address this, right? Let's try to make this a little bit better. So one of the first things you might do is start code splitting. So we saw that users downloaded just a single bundle, and no matter which page you navigated to, it was just the one bundle that was generated. And so our first approach here, you can see in our app.js, we are using just React Router DOM. We're just have a few different pages here, right? We've got the Pokédex page, the About page, a Pokemon page, and then a fallback no match page. And we're loading those all in right there. So as our first improvement, I'm going to comment that out and uncomment this next section one-handedly. It's going to be great. Come on. All right, I'm going to put this down for a second. All right, lovely. And then while we do that, I'm going to build the code real quick just so we don't have any dead time. So we're going to do npm run build stats, and that will build as we talk in the background. Okay, so now the difference here. We are using the features from React. We're using lazy and suspense, right? So rather than importing our different routes at the top of the page, we're now lazily importing them. So we're saying const Pokédex equals lazy, and then an arrow function that returns the import of that page. So we've now lazily loaded those pages, and then inside of each element, rather than just loading the one page, we're now wrapping it in that suspense component, and it will show that fallback, so that's where you might show like a loading spinner or something like that, right? So again, this is not new or groundbreaking. This has been around for, I don't know, the last several years in React, but it's often underutilized. So let's take a look at this now. We've built our code, and you can see the output down here in the terminal. We now have a lot of different chunks. You can see that one, that main, the second one, is now down to 86.35 kilobytes. It was down 150 kilobytes. So that's exciting. We've broken that up, and we've got a bunch of different smaller pieces. So now as we go run this, we'll serve that. By the way, I'm just serving the production build here so that we're not trying to like analyze the development build or anything like that. So that's why we're doing that. Okay, so as we come over here, I'm now going to hit enter as we load the home page. And you can see we've loaded a few other JavaScript bundles, right? So we've got our main.js that's now 87 kilobytes, and then 3 others. And so all in all, if you add those up, you get about 135, 136 kilobytes. So much, much better than our initial 241, right? We've dropped that down by a whole bunch. And now note, as I navigate around the page, if I go to, around the app, excuse me, if I go to another page, I click on that, and it downloads more JavaScript. So in this case, it downloaded an extra 110 kilobytes plus 5 kilobytes, so 115 for that page. So that's pretty heavy. But we've at least code split that out. And so in doing so, our users haven't had to download the entire app up front. They've only had to download a small piece of it. You can see then as we go to like the About page, for example, now only downloads 2.5 kilobytes. So that's a pretty lightweight page. So that's a pretty good first step, right? Users are used to a small delay between navigating between pages. And so code splitting by route is a great first step, right? We've now made sure that if someone just stays on the home page, they don't have to pay the cost and download the JavaScript for the other pages that they don't visit, right? If we were to look at this at the bundle analyzer, you can run this real quick. Let's do npm run analyze. Now we've got a different set of things. So compare that to the first one. Here's the second one. So we have some familiar ones. We can ignore the HTML2 canvas and the DOM purify and the canvg library, wherever that went. But we've got a couple smaller ones. So main.js is smaller. But we still have that massive JS PDF up there. And so that's probably the next thing we want to tackle, is we noticed that when we navigate to the Pokemon page, it downloaded 115 kilobytes just to display an image and some text, right? That's a bit ridiculous. We shouldn't need to download that much code. And so what if, on top of that, we know that not only do only a subset of people visit the individual ID page, we also know that not a lot of people click the Save as PDF button, right? Maybe we've got tracking in our app, and so we know that less than 1% of users click that or something like that. So we're making all of our users pay the penalty to download that code that they don't even care about or want to use. So as our second strategy, something we can do is a dynamic import. So you can see right now in the code, we're importing JS PDF. We have a save as PDF function. We're calling that as our click handler in this button component. And then all it does is just creates a new class of JS PDF and then saves the result. So what if we did not that? So I'm going to try to comment this out. And we'll get this next one real quick. 146. Thank you. I saw. What would win, a bunch of code or a curly boy with no friend? All right. Okay. So now we've done something slightly different. We're still using JS PDF, but we're not importing it up at the top up here. Instead, inside of our save as PDF function, we're going to do import JSPDF.then, and then reference that module, and then instantiate a new class of JSPDF from there. So really the same setup, except that we're not importing by default. We are dynamically importing it, right? So let's take a look at what that looks like. I failed to run npm run build stats. We're going to do that real quick. But yeah, basically what this does with this dynamic import is that it's not going to import JSPDF right when the page loads. Instead, it's only going to load it once that Save as PDF button is clicked. So let's run that real quick. Just want to serve it. Okay. All right, so check this out. So on our main page, we've still downloaded the initial 136 kilobytes right there, right? But now as we go to the next page, we'll click on a single Pokemon. We only downloaded 5 kilobytes, so much better, right? We didn't have to download that whole 110. So that's super nice. So if a majority of people don't actually click the Save as PDF button, they don't have to pay the penalty for downloading that, right? And it's not until I click this button that now it downloads that 110 kilobytes. And just as a note with how dynamic imports work, if I click this button again, it doesn't re-download that bundle. It's already there, right? So it just downloads it the one time. So that's our second tip, right? Use beyond just code splitting by page, try to code split by feature, especially if you have some visibility into your app and know the data of various features that are used. It can be handy to kind of split out these heavyweight features that not many people use. From there, we can go look at the bundle again. So we're going to do npm run analyze. Okay, is number 3. All right, so we're going to start out with 1. That's 1 right there. That's 2. That's 3. So nothing really changed between 2 and 3. We've got the same amount of code. A couple of the content hashes changed just because of how we're importing it. But still the same amount of code in there, right? And so it's kind of interesting is that as we've gone through this, the dynamic imports didn't change the total amount of code downloaded, but it did change when it was downloaded. Even going through the totals of all these, like if we were to look at this, again, a couple of these aren't used, but just looking at the full total, we have 349 right there. On this one, we have 349 kilobytes, and this one we have 339. So we actually added 10 kilobytes to our code as we did this, right? So we're kind of going backwards here. We haven't reduced our bundle size, but we have changed when the JavaScript is loaded. And so finally, kind of another question that we might ask ourselves is, do we really need to be using JS PDF at all? That's still a massive library. It's still 110 kilobytes when people do download it. And so final recommendation, if we go back to our slides for a minute, is to use something like bundlephobia.com. You can type in any NPM package and we'll give you some interesting stats about it. So you can see for JS PDF, for example, it's 107 kilobytes minified in gzip, so that's big. So you might want to look at some alternatives. So another tip, just look at those third-party dependencies and be conscious about what you add. Just as some other popular examples, if you've ever done like HTML sanitization, one package I used in the past at one point was sanitize HTML because I didn't look at the file size. I didn't realize it was 80 kilobytes. Very shortly after that, we switched over to DOM Purify, which is much smaller, right? 7.8 kilobytes. Same thing, moment.js, I'm sure you've all seen the announcement, it's dead, that's been a couple years ago, but moment.js is huge, compare that to datafns or day.js, and you get much smaller bundle size. So, wrapping up, we've got just a minute left here, so just the key takeaways. First off, use a bundle analyzer. You can't really solve your problems until you know that you have the problem, so get some visibility into your app, start looking at that. Number 2, use lazy loading to code split your app, at least by page route. That's a good starting point. Number 3, use dynamic imports to code split between heavyweight pieces of code. Again, try to use data to identify those features that you may not want to download up front. And then number 4, choose third-party dependencies wisely. Make sure you've got the smaller bundle sizes and not the larger ones. That's it. Thank you so much.
Thank you. Thanks for being flexible on the mind.